back from your break. Everyone had a good break. Because we had a long break, I added a multiple slides to review classes 1 and classes 2. Okay. The recording is not going to be the same, right? The recording was not at that, right? I added them because I know it's 2 weeks. We learned very important things 4 weeks ago. Don't remember, right? Let's review, and now talk about classes 3. For today, a lot of it already depends on what we cover classes 1 and classes 2. And there's a lot of contents today that will go along with, right? Including this pointer, that's what I'm going to talk about. Someone already asked a couple weeks ago, like, are we going to talk about it? Yes, I spent all those time talking about pointer. Is to prepare you to leverage pointer for everything that we're going to cover. And you will see that it will go a long way. Even the last week of this class, you will see me ask you to use pointer to do things that rely on your understanding of how pointer works, how it's different than reference, right? Why can't I assign things and reassign things at pointers? And today we're going to talk about this pointer, which is another type of pointer. So you see me also have a slide reviewing the pointer that we did maybe like a month ago. So that is, refreshing a little for you. All right, review. Okay, the first lecture that we have on classes, we talked about declaration and definition for header file and source file. How we group files into different folders and how people organize code. By the way, just from work today, someone's saying that, oh, I'm having such trouble hiring because it requires C++. I'd be like, oh, like I have a class of students who knows C++. And the reason that people try to avoid C++ and do like Java and Python and that of it is basically the complication that you're learning for second half of this semester that distinguishes C++ from all the other things. You'd be like, this is a lot that we need to handle as software engineer, where like for Java, like you don't need to worry about memory and things. It's just simpler. The compiler is more powerful to help for you. But with the powerfulness of those compilers, you lose control. In C++, you can do whatever you want. Don't have, but you can, right? All right, let's do that. Header file and source file is the fundamental of you understanding any of the C++ code out there because nobody put those together anymore with a big repository, which is like a way to talk about code folder, right? We call it repository. Understanding of header file, how we write it. We have the declaration preventer of if not defined, define, first 2 lines, and then at the very bottom and if. Right? Those 3 go together to make sure that every time you include it, you're not defining it over and over again. You see that the namespace, right? We want to make sure your declaration and definition are in the same namespace. For this class, you're okay to just use namespace std, so go ahead and do that. It simplifies a lot of things. And then in between are your codes for class declaration, right? Notice the semicolon, right? Make sure you don't miss that. You have a name, that's class, so for this one it's account. Then you have access specifier, public, private, protected. We have not talked about protected yet. We will talk about it pretty soon, I believe. But public is when everything is public to everyone, right? Whoever create an object that's account can change whatever inside that account. Private, meaning that only the class, only the in here or only in the definition of class function have access to private. Everyone else who create an object of account, right? Cannot change anything that's private. Next, we have setter and getter, right? Setter is a function for you to control write access. Getter is a function for you to control read access. And we call them setter and getter, but you don't have to name them set something or get something. It's just a practice that people kind of agree on. Engineers try to agree on. And then functions. There's a difference now between regular functions and member functions. Member functions are functions that belongs to this class and this class only. Without class account, span balance means nothing, right? The memory coming back. Now, source file. First thing in the source file includes your header file, right? The header file is what tell your compiler, tell your C++ that, oh, I have this class account. Without that, anything that you put here, anytime you type account, it's going to be undefined, right? No one's going to know what that is. Include the header file, and then do the rest of your code, right? And then reiterate, setting the namespace should be the same namespace as where you define your header file. Then we have member function. When you define your member function, you need to tell your computer it is a member function, not a regular random function, because you have the class name and the scope operator saying that I'm defining this function called setName from account class. Inside that function, basically you're inside the scope of account. You can use whatever you have, public or private, from the account, including name, the account balance. This is where you can access private, basically the only place you can access private. All right, the source file. Now let's look at what we talked about, right? Variable functions of members, right? Member, variable, member functions. Mutator, assessor, setter, and getter, right? We looked at that. Class interface, class implementation, completely separate, even in different folders nowadays. And that's where you house header files and source file. And then we did not cover protected, but we did talk about public and private. All right, how about 2 weeks ago? We talked about constructor and destructor, right? Special function looks just like a function, has no return whatsoever. It has the name that is the same as your class name. Constructor, exactly the same. Destructor, with the tilde at front, right? Can I change the name? You can if you change the name, it's just another function. It's not going to become constructor or destructor anymore. Only when you have those has the same name as your class, that's how your compiler recognizes, oh, this is a constructor, and that's a destructor, okay? For constructor, you take same parameter, because the purpose of a constructor is to initialize things for your object. What do I initialize them with? Can I only initialize all my integer with 0? No. You can take a parameter and set them to be non-zero. This is not a good example. I set it to be 0. But this is where you're taking parameter to as initial values for your members, right? Default. Default argument can only be in header file. I cannot iterate it more enough that if you put it in source file, your code will run. Is that default? No. Okay, this is when you're like, oh, I wrote this piece of code. Well, it doesn't really work the way you imagine it will work, right? So make sure when you put that in header file. When you go into source file, you do not need this anymore. If you put it there, it doesn't hurt. It's confusing, yeah, but it doesn't hurt. Your code will still run. All right, let's look at definition of constructor and destructor. Again, make sure you have the class name with the scope operator so the compiler know what you are defining. This is constructor of that class. This is destructor of that class. See, I did not have the default in here. Completely fine. All right, let's look at main. When you have constructor, you do not create an empty object anymore. When you create an object, put parentheses right after it will trigger the constructor. Now, one thing I did not cover was that can I not put parentheses? So we have a constructor for this object already, right, that you just saw. For that case, can I remove that? Will that work? It will work. Will I have the correct default value for my member? No. Then why would that work? Because for every single class, C++ actually will create what we call a default constructor for you. We're going to learn about default constructor later, but just for those of you who are trying the code and decide to remove it and see what happens and it actually runs okay, that's why. Your C++ will, for your class, it will create a default constructor that takes nothing and do nothing. All that is doing is allocating memory, right? You're like, oh, I need an int, enough space for an int, enough space for a string. It will do that, Would I put things in those space? No. Would I put 0 in the int? No, it would be like 5, 7, 8, 9, 6, 2, 1. Completely random. Remember the criteria of friend in C++? That's when we talk about friend functions and friend classes, right? For each of the class, you can grant access. You can only grant, you cannot ask, right? As a class, you can be, I want to be friend with this function. I want to be friend with that class. Does that mean that, oh, you are mutual friend? No. Okay? If you grant a friendship, one way only. I'm friend with you, right? Let's be friends. Like, I share everything I have with you. She's not going to share anything with me. Sorry. Right? But that's the way about friendship in C++. Well, how about group friends, right? I'm friend with you, you're friend with her. Am I friend with her? No, like, no. Okay? So very, very specific on friendship. Every single friend connection, you have to define. If A wants to be a friend with B and B wants to be a friend with A, define it twice. A define it, B has to define it. Okay? Now, what does friendship do? Like, why do I want to be friend? Sounds so bad. But why do I want friend? Because you may want to give access to specific function or class on your private. Remember we talk about private and be like, oh, if it's private, only yourself can access it and no one else can? Kind of strict. If I want to give access to one function, one class, two functions, two classes, then you can define the friendship corresponding. Okay? And that's the example that I pulled from when we talked about this is, this function need access to my private with friend and make it possible. Right, that's all we covered 2 weeks ago. We have constructor, destructor, default constructor, default parameter, friend function, and friend classes. Are we good to start this week's new contents? We have a lot to cover. First up, constant. You probably have seen constant, probably in C or other language, right? Constant means the same thing in C++ where you cannot change it. Constant. Now, when we have it on objects, on classes, it gets a little bit more complicated because you not only have constant integer, constant float, constant double, you now have constant functions. Now, how does constant function operate with my objects? So here's their relationship. Constant object can trigger constant function and constant function only. Non-constant object, like what we have seen, can trigger whatever. Okay? With that, you see this common layer of constant function. So if we go another way to describe it is that constant function can be triggered with whatever object, right? Constant or non-constant object. Non-constant function can only be triggered with non-constant object, right? So the first way was trying to explain ownership, right? What you can call. But when we are looking at function, because when you write code, don't look at like, oh, this object owns this object owns that. You think about, I write this function because I want this function to operate in this way. That's why you write that function. So a lot of time we think the other way is that, oh, I write this function. Should this function be accessible by any object that people create with my class, or should that only be accessible by non-constant objects? So we normally think the other way around when you write the program. Okay? Now let's look at our example. This time we have this class time, right? 3 private members, minute, hour, second. Straightforward. Down here, zoom in. We have constructor of a time, take 3 integers, right? And we have setter, that's set time, take 3 integer. And then we have 3 getters. Okay, so that's the setup of our class time. Let's look at our main. I'm not showing you the source file because just with this, you should fully understand it. You don't need to know how it's implemented. It's very clear, right? This set time probably gonna have this equal to this equal to that equal to that, right? Like get hour should just return the hour, get minute should return the minute, and so on. So we don't need source file. That's why I don't normally read people's source file. I just read their header file and I can go ahead and write my code. Similarly here, so I'm trying to have that practice when we are going through code as well. When we have an object time, I'm going to name it a long time, 7:35. This is a regular object, right, that you have been defining. Now when I have a constant object, I have const at front, just like when you have const int, const float, right? Should be pretty similar to that. You put the const, you have the type, you have the name. My constant time object noon, it's at 12 o'clock. It makes sense for me to have it as constant. I don't know whether there's other culture that call noon 1 o'clock, maybe in the summertime or wintertime. But when you want something that you don't want other people to modify, you set a constant. So similar to object. I have this object noon, I want it to be 12 o'clock. I don't want people to change it to 1 or 2, right? So I make it constant. Now look at the functions. We have alarm time, which is my object, right? It's 7:35, way too early, right? Let's do 9 o'clock. It's probably still early for some of you. But I can change that whenever I want, right? I can just change it to noon if I want, and then wake up at noon. But for noon, if I want to set time, it's not allowed anymore. The minute you write that code, you have this marking. Now what does that mean? If you hover over it, it will tell you what it means. You look at here, constant time noon, constant object. Constant objects are not compatible with member function. Right? What's constant object compatible with? Constant member function. Remember our first diagram, right? Constant can only trigger constant. Constant cannot trigger anything else. All right. Now, how about our getter, right? Our getter is also a regular function. People may be like, oh, what's noon for you? For whoever write this program, they want to be like, okay, tell me your noon hour. Reasonably, they will call noon.getHour to just read the hour. For constant, we don't want to change things, sure. Should we not let people read things though? Right? For constant, we don't want to give them write, but we should at least give them read, right? Readability is something that we would like to provide when you're designing your class. How do we have the getter to be constant function? Very important slide. People got tricked by this all the time. When you define constant function, const go at the end. Okay? At the end only. If you put it at the front, what does it mean? It means I'm a regular function, I return a constant integer. Has nothing to do with constant function. So when in your project assignment, I'll be like, oh, write this constant function. And I will ask you to create a constant object, and it will not work if you call this function and you send me an email and be like, oh, I have a constant function, I have a constant, why doesn't it work? And I'll just be like, put your const at the end. That's all that you need to do. It's a little counterintuitive, but that's really important because those mean completely different things to your compiler. Yes?
What does it mean if you put it in the middle?
I would like to know as well. It probably will break your code. If you put it in the middle, like int const get hour,
Yeah.
I think you're going to get an error.
Okay.
You try. Ask ChatGPT. Alright. So here's our modified version of our class where we have all the getter to be constant so that when we have a constant object, we still give people read access. We still want them to read what's noon. It's 12 o'clock. Like, tell me, show me, it's 12 o'clock. With that, here, Oh, before we go to the main, let's look at definition. Const is part of your function signature. If you don't have this, you're defining another function. Your signature needs to match. Remember, when you define something, that needs to match your header file. That includes the const in here. All right? So when we define it, we are also doing const at the end, okay? Not at the front. Oh, yeah.
I have a kind of a crazy question. What if you do const int function and then const?
Good question. That means you have a constant function that returns a constant variable, right? They do not conflict. They do not conflict. You can have a constant and return a constant variable, of course, no problem. All right, with that, our main will work as intended. We have constant variable noon, constant object noon, right? We have regular variable alarm time. Alarm time should be able to set time whenever we want. Noon should not be able to set time, but should be able to read. Okay, it should be able to get all the variables. With that example, I want to tell you a good practice for engineers is that we want you to put all your gather functions to be const from this point. Okay, so after today and when you write code, put all your gather function const because you are the software engineer who designed the class. You are not the only one who will use that class. Millions of people may use your class, right? Imagine the plugin that we download. How many people downloaded that plugin? Do we think everyone's going to use the plugin the way that's designed? You don't know, right? So when you're designing your class, you want to have the mindset of other people will use it in a way that you may not use it. But if you have constant for the getter, you basically avoid someone ping you 2 a.m. and be like, you have a bug, fix it, right? I don't have that life, but I guarantee you some software engineer. When you write those, what we call pretty safe code, it's safe for yourself, right? So that's why I highly recommend, for this class, I'm actually asking you all to just put gather function constant. After this class, when you're done, be like, oh, I forgot about Jen, who's Jen? Please, 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 still continue to do that. It's a very good practice for you. All right, now let's go to pointer. The pointer that I'm going to talk about is special called the this pointer. Before that, let's look at how we've been writing classes. Remember, I have been using something like that randomly, and sometimes I don't have it. Now I want to tell you why. We talk about when you're in We talk about when you are defining a member function of a class. You have access to all the public, private, protected member of that class directly, right? However, how do I tell my compiler what am I getting? Am I getting the hour that's a local variable? Am I getting the hour that's a class member? This is one way to tell it. This is the way that I showed you. Because it's very clear that this is saying that the hour from time, right? The minute from time, the second from time, right? So I was trying to show you this for readability, but after today, you will know that what it actually means. We're going to talk about static. This is static. So for the other way of me showing your code, remember this? Where I just don't even include it sometimes, right? I just have hour, assuming that it knows it's the hour from class, from time. When I just say minute, I assume that it knows it's the minute from time. Because what will compiler do? Where will the compiler look? It will look local, try to find it. If it doesn't find it, go to the class. And it will find it, right? We have time, we have minute, and we have second. However, people like to, especially for constructors, like to name their parameter the same as the variable they're initializing, so that it's very clear for whoever's reading your header file what they should fit in, right? If in your parameter you put in, like I did in the previous example, I mean, it could be hour, millisecond, it could be millisecond, hour, it could be second, minute, hour, like I don't know the order. But if I say int hour, int minute, int second, whoever uses it know that the first number they're gonna put in is the int. Sorry, it's the hour, right? The second one is the minute, the third one is the second. Very good practice, however, that does cause problem. When I have things like that, sure, super readable, and header file's nice, other software engineers are really happy. But when I write my own code, you could confuse yourself. You're like, oh wait, which hour is which hour? Whenever you're confused, I guarantee your compiler is even more confused. Okay, your compiler will be like, no, right? I do not understand this, and it will try to interpret. VS Code is less likely to interpret. Visual Studio, I guarantee you it will run and not the way you expect it, because Visual Studio just makes everything for you. So how do we avoid that? Do we have to do the second part where we have to change the name, right? Where you have a variable A, I have AA. Where I have B, I have BB. No, right? You don't have to, because there's a way around it. This is where the des pointer comes in. Des pointer, it's a pointer. And the way that you use that is you just write the keyword this with this pointer thing, right, that you probably have seen quite a lot. And this is telling your compiler the difference between the local variable and what we call an object variable. There's a reason I do not call it class variable, right? So let's see why. What is this pointer pointing to? When we create object for our class, like those two lines, your this pointer point to the object, meaning that the variable, remember pointer, how it works, right? And pointer is an address. So it's the address of the object. Well, okay, if that's the case, does that mean that every single object have this variable that's a pointer called this? No, it's a dynamic moving pointer that's shared. Okay, we're going to show you the memory drawing again so you know how this pointer point to. But it is not part of the object itself, meaning that you don't have a copy of this pointer for every single object. You do not. Right? So if you look at this here, we have alarm time, we have noon. When you were triggering set time, which is the function, from the object alarm time, okay, at line 9, this pointer points to alarm time. The minute you got to line 11, where you're calling function get hour from the object noon, this pointer points to noon. It points to the object that's triggering the function. Let's look at that in the memory drawing. So when you create an object, it happens the same thing. This pointer is always around. Line 8, when I'm creating an object noon, my this pointer at line 8 points to noon. The minute I jump to line 9, alarm time dot set time, this pointer points to alarm time. And then if I jump even further, back down, it comes back to noon. Now you'd be like, this is so confusing. Like, how do I know what this pointer is pointing to? It's just switching all the time in main. Because if you notice in main, we don't use this pointer at all, right? You do not use this pointer when you're triggering. You use this pointer when you're defining those member functions. Now let's look at the difference between the two, and then we'll talk about it. The first one is the one that I've been showing you and you probably are most comfortable doing. It's just return hour. Hour is a class member, compiler's gonna figure it out. Sure, you can do that for this case because there's no conflict at all, right? Why do people do it that way? Because they want to say that my minute is the minute from the object. Is that any different than that? It's not different. Okay? This is super clear when you have another local variable minute. And also it's required for the third case, which we'll talk about. But remember this, when you're defining function, right? You have get minute, and you're going to trigger this get minute from some object that's of time, noon or long time, right? That is saying that I'm getting the minute from that object. Remember noon has a different minute copy compared to a long time? So this is saying that, like noon minute is 0, right? We have 12 o'clock, so 12, 0, 0. So that will give you 0. For a long time, we said like what, like 7:35. This will give you 35. If you have the this pointer, it's super clear that whenever you call this function depends on which object you're triggering from. Are they both from the same class type? Yeah. Are they same minutes? No. They're different copies of the minute, belongs to different object, which represented by this. With that, this is possible. Because my this pointer always points to the object that's triggering my function, there's a possibility now that I can grab that object inside the function. And the way that you grab the object that's triggering the function is by dereferencing. The reason that this is equivalent to that is that this is just using the this pointer. What does this pointer point to? Noon. Where do I get the minute? Inside that noon, right? How about here? What is dereferencing this? Noon. See? Where am I getting second? From the object noon, therefore I use dot operator. Remember the difference between dot operator and the pointer? Right? This is where you grab things from the pointer. This is where you grab things from an object. Any question on those two? Very important. Let's start with this one. Yeah.
Are there any differences between the last two methods?
For this one, this example,
The
no.
last two, yeah.
Yeah,
But
for
you-
this
you
example
refer-
where you're just getting something, no, right? This is where you are using the address stored inside the pointer. Hope it works. This pointer, right? This is a pointer, and then you have x 8 6 7 5 2 1. For example, that's an address, right? That's this pointer. This is a pointer. This is a pointer type, and that's that, right? Now, this one is saying that, okay, now we're gonna have another bigger box with an address 8 6 7 5, blah blah blah, right? The second one is saying that, okay, use this pointer, what it's pointing to, which is that, grab minute. From here, so this will return to that line and print that out. That's that one. Now this one is saying that return this whole object. Right? That's what this is. This is saying that give me this. So it will give you this. And then from there, you grab it. No difference, to be honest, right? Yeah. That's what we're going to talk about next. So now you understand those three, you can talk about cascaded function call. Like, why do I go through all the trouble to get the whole object just to get the minute, right? You don't, but for other scenario you do. Oh yeah, I have this. I'm going to draw this. I have this out. So review of the dereferencing, right? The difference is that you have a pointer. This is the same exact example when we first talked about pointer. You have a pointer, you have a name, you have an address in that pointer. when you're grabbing things, you can say, go to where you're being pointed at and grab the value. Or you dereference that, meaning that grab whatever's inside the object, which is this whole thing. That's that, right? And then you can do something on top of it. Which is this, right? All right, let's look at this. This example is why people use dereferencing. A couple of things here. This is a setter, right? That's going to set this hour to the parameter that we pass in hour, right? So this, in this example, that is the most common way people write setter. They tend to use exactly the same name for consistency and use this point to distinguish them. Super common, very pretty code, very good practice. I'm shameless calling myself writing pretty code, but very, very nicely designed code, okay? Now, return dereferencing. What this is saying is I'm returning the object. Now, why am I doing that? This is the different object than that object at this line, for example, because I changed something. I changed the hour. So in a way, what I'm returning is the updated version of my object with the new hour. That make sense? Right? You're returning the updated object because I have line 12 that already updated the hour. Right here, when I call start this, that's the old object. Here, when I call start this, that's the new object, the updated object with the new hour. Another thing we're going to talk about is return by reference. So we're also going to talk about that. But that's the three things I want to point out for this example. That's different than what you have before. Now, why? We have the this pointer that points to object, which gives us access to the object alarm time. All right, so it's the drawing down there. So my alarm time, let me zoom in a little. My alarm time is triggering my setters. At line 9, this pointer throughout line 9 are all pointing to alarm time, right? Let's look at it one at a time. When we are looking at just the first portion, the alarm time is 7:35, right? That's where we got it from. Alarm time is 7:35. Noon is another object, we don't care. Alarm time is 7:35, right? What do we call the first function? Set hour. How do we define our set hour again? Here. A couple of things, right? Set hour, return the updated version of the object by reference. Remember that? Therefore, that bracket of code, right, only up until set hour 9, okay, ignore the rest, just up to here, that will return the reference of this 9:35. Right? You good with that? Because this bracket returns an object alarm time with 9:35, I can run object dot set minute, which is this portion. If my first function, if the set hour 9 does not return an object, I cannot use dot operator. Right? So this is saying that, oh, okay, I can continue to call dot set minute right after I finish call dot set hour because it returned the updated version of the object. That's why this is possible. The way that you can call function after function after function without a break is called cascaded function call. the set minute will return the updated object again, which is 900. With that, you can then call that second, right? And that will give you the final object, 9 o'clock, as your alarm time, return as the object. Yes?
Can we do like set hour, 9, and then skip set minute, go directly like dot set second?
Of course. Those are just function calls. You can call whatever function you want, as long as it's cascadable, right? Cascaded function call allowed it to be returning this part, returning that.
It's fine if you skip one of these. Like,
Yeah, because all 3 functions have exactly the same design. So any function with that design, you can call it. Meaning that because I have the same thing for dot set second, I can do dot something else right after. But if I don't have that, you cannot.
Yeah, thank you.
Right? Alright. Now you'd be like, oh, cascaded function call. This is so new. You have been using it from class 1. The first week of this class, in my example, I have shown you cascaded function call. You just have not realized. This is when you write code and I tell you, be like, do this. And you'd be like, she said do this. I'm going to do this. This is the way C++ works. Because I hide some detail. Remember how we print? Remember CL? Remember we showed you an example where be like, just use this as print. You can just continue to print, right? You have print. You print time. Do you have to break it?
You don't have.
What do you do after? You continue. What do you think that returns? Why do you think I can call this right after that? This is cascaded function call. This operator, we're actually going to teach you how to write operator. This operator return cout. Return that in this definition. Because of that, you can do this. Otherwise, this is not impossible. So you have been using cascaded function call the whole time. Just with operator. But you can see that, oh, that code is pretty nice now. I can just do set hours, set minutes, set second. That helped with code readability, and that also helped with people writing code. Imagine that every single thing you have to do a line break and do it. Your code is not in the place, right? Now let's look at the last part, which is why did we return by reference? What's the difference between regular return versus return by reference? By default, remember, C++ always operate on value. If you don't tell it to do anything, it's value, value, value. Copy and copy, create copies. Therefore, by default, C++ return by value. Everything we have done so far has been returned by value. I just omit that fact when I tell you, just write this function, it's going to be fine. Right? Now that we learned cascaded function call, that's when you see that, wait, you can return by reference? Yes, you can. Let's look at return by value. What does it mean, right? It's probably as expected that when you have a function call, sum 3, 5, sum A, 3, sum B is 5, right? And you have a local variable created called S, that's equals to 8. That equals 8, right? Now, everything belongs to sum. That's why I have the sum column A, B, C. When you return S, what's being returned is not S. You'd be lied to. It's not S. What's being returned is a variable called summation belongs to main that you have from here. Then what happened to my S? I'm sorry, it's gone. What is S again? Local variable of function sum. What happens when things go out of scope? Destroyed. Remember? Now it makes sense, right? Like, oh, right, yeah, she talked about being destroyed. Never thought about the S because, yeah, it's being destroyed. Where is preserving? It's in main. It's another variable called summation. Its main does not belong to sum. Now how about this? When I have an object, right, a long time, 7:35. I'm going to set hour 9, that's the function call we did. When I set hour, my this pointer points to a long time, right? We talked about that. And then my hour is 9. Now where does hour belongs to? It belongs to the function set hour. That's why I have set hour, column hour, because there are multiple hours here, right? So that is 9. That's good. Now I'm going to have equal. Right, so my this hour, which is up there, turning to 9. Right, that's what that line does. You have a local parameter called hour. You're setting that hour to the object hour, which is this. So when I run 12, it's 9. Now, what happens at the end of the scope? Everything inside the scope got destroyed. So when I am returning the object, right? Imagine that I don't return by reference. You're going to have another object being created. Do you want that? No. The reason we use this pointer is that we're operating on the original object. I don't want any copy being created. I just want this. I just want the original a long time. When you return, you better return the original a long time. And the way you do that has to be returned by reference, because this pointer points to that. When I return by reference, I got that instead of a copy. Does that make sense? Any question? Yes.
References can't edit like without. If I pass by reference an integer, I can't edit the integer. Wait.
No, that's
wait, no.
the other way around. If you put a copy, then we only modify a copy. We have a reference, you got to be able to refer back to the original object, which is what we are trying to do.
Hey, thank you.
Any other questions?
Oh. This is a predicted like keyword, right? Like you can't
That's right. That's right. So you see that the code is color coded for you. Whenever I write this, it's blue. Why is it blue? It's protected keyword. Right? It's a special keyword for C++. That's right. Good question. Yes. Oh no.
No, just sorry.
All right. So we talked about this pointer. Now let's talk about static. This pointer is object scope, right? Meaning that this always points to object. Noon, alarm time. That's why I never said that it points to the class time. Why have I been avoiding that? Because there's something that could belong to class time that has nothing to do with object. When you have variables, members, right? Could be member functions, could be member variables, that belongs to a class, we call it static members. Scope operator, remember the time column, is actually designed for you to access static. But then we have been using it fine. Why? Okay. I'm going to show you. Before we do that, let's go to my favorite drawing diagram. A static member belongs to what we call class scope. So imagine you have a big box. That's the scope of time. Time is a class. It's one class, one scope, big box. For the time class, you can have multiple objects. Alarm time, noon are both objects. They are object of class time. Okay? So that's why I draw a big box, and I have smaller box. Class scope, object scope. Now why do I split them? Sorry. It's a wall of text again. Before we talk about that, some ground rule for static members. To be honest, I write those block of text so that when you take quiz, it's easier for you to find them. A static member must be initialized exactly once, right? That, remember, we're going to show you how in the next example. Static member is initialized by compiler before main runs. I will also show example how that runs. Fundamental type static data member are initialized by default to 0. What's fundamental type again? Integer, float, double. What else?
Boolean.
Log. Boolean, yes. Those are fundamental type. Now, good question, good mention of Boolean, however, because when I default it to 0, remember Boolean is also 0 and 1, right? It's true and false, yes, but represented by 0 and 1. So fundamental type by default, static member fundamental type by default is initialized to 0, so remember that. Constant static member, now we're compiling things together. Constant static member needs to be initialized by you. Okay, it will not be automatically initialized. Alright, something that also just for you to easier search for, I'm going to draw a diagram to show you exactly what that is. A static member can only access static variables. Static function only access to class scope variables. Static variables are in class scope, which is why I draw that big scope. This pointer in object scope, so static functions don't have access to the this pointer. I will also draw that in the diagram to show you that. And you can still use the this pointer to access static member in non-static, but it's not recommended. You see that I do a lot use this recommended thing. This is just from my work experience and seeing other people's code. That is it required? No. Is it recommended? Yes. Okay. All right, let's go into actual example to show you what those tags means. Scope. We draw this. This is not supposed to be orange, but red. It's supposed to be red. Red box of class scope. Right inside that we have black boxes. Those are object scope. So inside the class scope, that's where the statics are. If you look at my definition, I have regular, static constant, static integer, static function. So there are 3. Because they're static, I'm going to put it in the big box, the red box. Constant int, get max. Now, when we have static members, they need to be defined. This is special for static. Remember in the big block of text, I said something like, static get created before you even start your main. Therefore, you cannot just do like hour, minute, and second where you just initialize them wherever you want. Static has to be initialized first thing in the definition. If you don't initialize your static, your code will not even compile. And yes, I got emails saying that Professor, my code won't compile. All that I reply, just need one line, initialize your static, and it will compile. Right? Especially in the later project, you have hundreds of lines of code, and you send that all to me and be like, no, first line, add this, everything else will work. So remember to define your static variables the way that you define them. Just similar how you define regular variable, right? Type, name, value. Type, name, this is by default 0, right? Do I like to do this? No. I initialize all my static. Like, I don't want to go and be like, oh, right, this is a fundamental type. Oh, right, this is not a fundamental type. No, I don't bother. I initialize everything. I like that alignment with my code. Also, it's fault tolerant. Right? When you initialize it, it will never hurt. But do you have to initialize it? No. As long as it's fundamental type, you don't. You can just do this, completely work, that'll be 0. And it's defined. Okay. After it's defined, then you can start using it and your code will compile. Alright, now at main. which starts at line 6. The first line of code in main starts at line 7, right? 7, right? When we're at line 6, meaning that I haven't even started running 7, this exists. This is already in your memory. The minute you start main, all your static started. Meaning that I don't need any of this for me to graph that max minute or max hour, which I'll show you in the next example. So line 6, we have this. Now, well, how about line 7? Well, line 7, you create an object. And that object has its own scope, called object scope, and it's black. Red, black. Red, black. Black scope is in black scope. Red is a box. Well, what if I create another black? Yeah, you can. It's in the same red box. Now, why did you spend all this time making this visualization? Because let's look at line 9. Line 9 is calling a function from no object. It's calling a function from my class time. Because getMax is a static function. It does not bound to a long time or a noon. Those are black. I'm red. Therefore, this is totally possible. This is not only possible at line 9. Yes, that. You can move it to the very beginning, and it will work completely fine. This is what I was talking about. Do I need object for my static to work? No. You don't need any object because the box, the red box, exists from the very beginning. I can call my static regardless of what objects I have, because object is in their own scope. Question on that? Now, how about why do you draw the black box inside the red box? Because they actually share the same red box. They are shared. Static functions or variables belong to class scope are shared across all objects. That's the special of static. Static is shared at the class level, where objects are in object levels. They have its own copy of hour, own copy of minute, right? There's its own copy of second. They share max minute. They share max hour. They share getMax. Now remember when you call a function, right? I said that. Remember, yeah, you have the this pointer, and then you can call getMax from noon. Completely fine. What you are doing is you are inside object scope where this pointer exists, but you are calling up from a static function. Is those two confusing? Absolutely. Why no without line 9? Why know whether those are static? You will not. Why know that I'm scope creeping? Cannot, right? This is object scope. Be like, no, I'm calling an static class scope function from an object, which makes no difference, but it looks like it does. Two different lines of code calling exactly the same function. This is not even the most confusing part, because imagine you're modifying static from object. You're confused everything. Because it essentially be like, wait, this is changed already. Wait, I'm changing it again. Because they are shared. So highly recommend completely split how you trigger, how you write static from object. From object, stick with this pointer. This pointer, always point to object. This pointer only exists in the back box. When you're calling static, use the way that you should be using for static. This, super clear, getMax is a shared function by all time. This is a static. Not just function, similar to variable, right? Static variable are shared across all objects. All right? Meaning that if I change max minute from 0 to 60, okay? Now when I have, I'm just going to go through this in here. Now that we have around the set time, that's 9, right? So the bottom we have 9. Time get max will jump up. Get the max here, that's class scope, right? Set time, object scope. Get max, class scope. Noon.get max, class scope. Confusing, yes, but class scope. Alarm time.get max, class scope. You see why I recommend you not to do this? Right? Up until this point it has been really clear, and now it's very good. Alright, so if I have noon dot max minute, you're not getting max minute from here. Yeah? You're getting max minute from here. If I change it to 90, change for all objects. Alright, I don't have an example, but be very careful. Alright, now that's static. Why static? Static allows you to create something that's shared across all your class. You see that the one that is set as static for my previous example have max hour and max minute. Those should be shared. Right? That should be shared across all my time object. That's where you put those. Very common to have them constant as well. Because once you set max, you probably don't want it to be changed. Another thing, and this is the recommendation that I said, right? If it's object scope, please use this pointer. If it's class scope, please use class scope. The scope operator, that's for class scope. Okay. A couple things where you're defining static. Like, okay, now we know how to use it, and now we know where it's pointing to, which function we're calling from what box, red box and black box. When should I decide to define this non-static? When should I decide to have this static? A class function should be declared static if it's only changing static. Remember the box, right? If functions in here that's only interacting with variable up here, they should be in the same space. Can I have function in here that modify those? Yes, you can. Will I be miserable? I guarantee you will be very miserable at some point. Okay? Therefore, I recommend it to have function that only operate on static, stay static. They're in the same scope, super clear cut. I know exactly which scope it is and which scope it is working team. Okay? Another thing that we already mentioned, right? This pointer belongs to object scope. You don't have the this pointer in class scope because there's no this. There's no object. Right? This pointer point to object, so this pointer belongs to object scope. To make your life even more miserable, people sometimes will use this pointer to point to static scope object. I do not like those. Okay? Not only make the software engineer confusing, make your colleagues confusing. Someone's gonna ping you 2 a.m. in the morning and be like, fix this. Alright? So the way that you prevent that or prevent yourself from forgetting and be like, oh my god, static scope, this scope. What am I doing again? Like, where am I? Is to have the static function because static function does not have access to this pointer. So you won't risk doing that. Your compiler will be like, no, 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 no. The static function, you have this, right? So that's also why it's a good practice. And we talked about the last one. The static member can be accessed before any objects created because they have nothing to do with each other, right? All right. Use cases. The most common use cases that we already showed, right? Constant, static, that's shared across object. There's another non-constant common use case for static, count. What's that counting? Counting how many objects this class has. Super common, we will be using that. When you want to count how many objects from the same class being created, it has to be static, right? Because it does not belong to any of the object scope, it has to be shared across all objects. Alright, out of scope operator. We talk about scope operator that to use to define static, right? The scope operator, the column, not only allow you to jump into a scope like class scope, it can also be used to jump out of scope. This is optional content, we will not be using this. But if you're reading someone's code and be like, that's a bug, that's not a bug, okay? You can jump out of your current scope to get something. We have two num, one inside the main, one outside the main. When I grab num, this is local variable. Well, I want the one out there. So we can do that. If you do the scope operator, it means jump out one level and then find num, and it will find num. Optional. Alright, finally, templates. We have talked about templates with function. Let's talk about template with classes. Those two are very similar, but there's a difference, right? When you do template class, here, when you find that, the same thing. You do template, you do class T or U, right? And you just use the T or U throughout your class, just the way that you're using any other type. Right? Just T everywhere, whatever you want. Now, when you are defining those, here, this is a constructor, and this is a function, member function. When you are designing, we want to make sure that we are not defining the member function of a class, but a member function of a templated class. You need to include the template marking. Instead of pair, you need to be pair type T. Similarly, when you are triggering those, you also need to include the type T. This is also different than function, right? Function, you need to do anything. For template class, you need to say template class for int, template class for double. Now, why? Always ask why. Remember how template works? When templates are generated, when you're triggering it with specific type. Now here, say I trigger those with no type. So I have a pair, my pair, that's integer. I have another pair called my pair double, that's double. That will generate the top part of the code when it's compiling, right? Pair, integer, 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 integer. Also, pair, double, 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 double. Can we overload a class? You cannot overload a class. Can I overload a function? Yeah, you can overload a function when the types are different, remember? You cannot do that for a class. Every class name needs to be distinct. So the minute you do that, error. Well, did I write those code? No, you did not. Are those code generated by the code that you write? Yeah. So still error. But if I have that, you see the generated code is still the same, but the name's different. I have two classes. I have a class pair of int. I have a class pair with double. Now we have two distinct classes, and that is why for class you need the type specifier when you're templating. When you're templating. Yes.
In the slide before, why is there a question mark between A and B? Like in the slide before, not this one. The one before this. Yeah, that one. It's just like in max and line 24.
24.
Why is there a question mark between B and
Oh, you found a surprise. I forgot the surprise. This is to prepare you for the later class. Those are all called operators, right? In C++, there's only one operator that goes in 3. We have single operator, that's single, one operator, and one operand, like not, remember the not? Or like this, right? Operator and a variable, that's single operator, right? Not true. This is mostly the code. Single operator with that. You also have double operator, right? A plus B. Operator, 2 operand, right? You have operator that can be single, can be double, right? In the entirety of C++, there's only one operator that takes 3 operands, which is what we call the condition operator. This and that together. The reason I hide that, because I do not like people who write it that way. But when you're attending a hackathon, when you're attending a code competition, where the goal of those are fast writing, okay, short. What does that mean? Condition if true, else. So that is equivalent as if A greater than B, return A, else B, return B. Right? Sorry, did I just write Python? I am so sorry. Close enough. C++, there we go. C++, right? But yeah, you probably want this. Right? Now proper C++. Now that people don't need to ask me, what do I write in my daily job? Alright, that's what that means. Condition, what you return if true, what you return if false. In one line, that is equivalent to that. Is this readable? Absolutely not. Is this fast to write? Absolutely yes. Do I like that person? No. But will I teach my students to do that before they go to hackathon? Absolutely. Right? If you need to write a piece of code in competition in an hour, do that. But yeah, in the later on of the semester, I will talk about operator, and then I will also talk about this operator. This is the only one in C++ that have two operator operate on 3 operands. Only one. But yeah, it's called a condition. Yeah.
I think it has a different name, mechanical.
Different name in what?
That operator has a different name.
Condition statement. Ternary?
Oh yeah,
What was it?
yes. Good call. Yes,
Better?
someone said this.
Yeah.
Yes.
Hey, Wilbur.
Good job, whoever spotted. Good job. All right. Yes. We were talking about template, and then we were talking about template. Right. Template with the name, with the type. Right. How about template specialization? You can do that for function, right? When you want a specific type of the template to do a specific thing, you define that. Similarly, do the same thing for class, right? You just put template, and then you say what type you're specifying. String, sure. Let's template the string, and just define it. How you like it? And so for this example, I have my pair integer, my pair string, and when I am trying to get max for string, I want to get special string. Right? But then for anything else, just compare them. Yeah? So this is template specialization. This is just the same as the one function. Okay? No surprise. All right, we're done. We talked about constant, the this pointer, how the this pointer allow you to do cascaded function call, why do we return by reference, static, class scope, scope operator, and templates. And that's everything about this. Right? Class 1, we have class. What is a class? Getter, setter, interface implementation, header, source. As a specifier, we still have not talked about protected. It's fine, we'll talk about it later. Constructor, destructor, debug parameter has to be in header file. Okay, call that out. Friend, one way only. Constant, we talked about it today. Constant function, constant object, has a special relationship. This pointer is in object scope. Static is in class scope. Cascaded function call, which you have been using. Now you know what it is and why. Return by reference, you know why now. Static template with class. Congratulations, you have finished the class, and congratulations, the quiz is finally released for you today. You have 1 week to do that. Starting next week, everything will be object-oriented. This is the start of officially C++. Okay, everything before, not object-oriented because we haven't got to object. Now you know everything about object. From today, I want you to start writing object-oriented code. From today. Okay? I mean, did you submit your project? When is it due? It's due, right? Yes, then from today. Yes, from today. For the next one. Okay? So what I'm going to release today is extra credits. In extra credit, it's worth a lot of points. 5%. 5%? I don't remember. I think 5% of your total grade.
Yeah.
Addition to the 3% of the quiz, right? That's a total of 8%. Your extra credit project assignment is asking you in a week, turn your project into object-oriented program that works exactly the same way. So we're going to go talk about that right after this. Alright, this is a very short lab, so you don't have to follow. It's the same thing that as the lab 3. But this will allow you to run multiple files together because now we have multiple files. Right? Header file, a source file, a main. Remember at the very beginning of the lab 1, I said to have a folder per project? And you were like, oh, I don't have it and it's fine. Yeah, it's fine until now. You want to have a folder per project because instead of running one file at a time, the compiler is going to browse through everything inside your folder and compile them into one single project. Meaning that if you have multiple main, it will break. If you have circularly include, it will break. So make sure that each folder only contains one project. With that, we're going to change the same thing like last lab where we changed the middle compile statement, right? This is find, compile, and run. The compile used to be compile one file, output compilable. Now we want to change it to compile all file. Start meaning everything that ends with .cpp. The way you change it is the same as last week. Go to your preference, go to your settings, go to executor map, add it in the setting of the executor map. Right? Find that C++, setting preference, executor, type in executor. And then there's a setting in JSON, add a setting in JSON, take that, and and then find C++. So you find CPP, you have something like CD, right? G++, we added this, remember? The left 3, we added that. Now we're going to change that to star.cpp. Save, close it. Now you run, it will run. Executor. Now. Setting. Yeah.
When you said one of the things would be having multiple mains would cause it to fail, what was the second thing that would cause a failure?
Oh, you have wrong include statement or include circular. Right?
What is include circular?
If you include a .h in the .cpp, you include the .cpp in the .h. Right?
Okay.
The include statement, because it's trying to compile everything together, it's going to link them. So the include will link them. So if you have A linked to B, B linked to A linked to B, it's going to create a circle, and it will fail.
Thank you.
Star.cpp. Change the file name, change the $sign file name to star.cpp.
What did we add last time?
C++ 14, the one right in front we added. Alright. Some of you added it. If your default is anything below 14, you have added that.
Oh, okay.
But if you don't, then you may not have.
Replace the dollar sign.
Replace the $sign file name, the whole thing, with star.cpp. Save, close. Then you're good. Right? Now the way that, remember the way that you have your folder is only the project relevant files are inside one folder, otherwise this will break your code, okay? If you have everything all together in one single folder from before, those will not run anymore. Have to separate them because now it's scanned through single folder for everything and run it here. Compile it here. Alright, this is optional, but I will keep this because if you decide to not to use debug for this semester, you will need this after this class anyway. This is to set up so that it debug multiple files in the same folder. This is a little bit more complicated because it depends on how your launch.json or task.json is being set up. Some of you don't even have it under .vs Code. If you do have it under .vs Code, all I need to do is go to task.json and find this arguments, arg stands for argument. Inside there should be a .g file, .o blah blah blah. Replace the file with file directory star.cp. Okay? Now if you don't have it, I upload it on campus. If you don't have it, you will at least have an empty folder called .vs Code if you started a project like we talked about in the first lab. Right? Then you should have at least that folder. Grab the files. I have a Windows version, I have a Mac version uploaded on Canvas. Grab the corresponding one for your system, put it inside that folder, and then try to debug and issue. Hopefully, because every year you change. So if you have trouble with the file that's downloaded, email me and let me know. Show me your error message, and I will complete it. Or rather, come to class next week. Bring your computer. I'll debug it for you. Okay. All right. Extra credit. For extra credit, we are rewriting. Okay, we're rewriting Viva Mac system in an object-oriented way. So first of all, I simplified the input so that you don't need to spend time that you already spent time on from the previous project. The input would just be 2 lines, the number of plot boss power and boss power, that's it. Okay, so we're not gonna worry about the default because we have learned constructor, you just write it in now. Right? Before you have not learned constructor, then I couldn't ask you to do that, but now you can. So now the file is gonna have 2 lines. Again, this file examples uploaded right under the extra credit project module on Canvas. You can just download it. Main is provided. Okay. Sure, I have some to do where the open, read, and open and write. You can just copy and paste those from your previous project. That should be all you need for your main. Therefore, your task for the extra credit project is to write those classes so that my main will run. Okay? So if you look at main, there's 2 classes. We have battle, we have mech. Battle has a constructor that takes in 3 variables, right? You can kind of see that from my name. Diva is a class mech object. We have our calculation. Those calculations now belongs to battle object and mech object. Similarly here, the low function belongs to mech object, and that's it. Output should be the same. Alright, so here are some detail. Again, if you want to be challenged, you don't need to read those details down here, but it's not like as much as how I provided from before. Like I said, right? As the class go on, I'll slowly remove all the detailed instruction and give you more and more freedom to decide what you want to do. For this extra project, extra credit project, oh my God. You will not need to use template. You will not use function overloading. You will use friend. Similarly, for boss power, right, size 10, you can directly calculate missile power required from boss power and boss power in function because they belong to the same class. You don't need to worry about variable anymore. You can just access it. You'll be using Mac load to load diva, and you will have the default variable for defense matrix and micro missile hard-coded inside your constructor, because now you know what a constructor is. Constructor can have default parameter. Here are some more detail. Battle has boss power array, boss count, boss power. Remember flexible array? Make sure when you have that as a member of your class, this is the last member of your class. Okay? If you want to use pointer, go ahead. If you want to use pointer, be sure to write the delete in destructor. If you don't want to deal with it, just use what I'm giving you and just make it as the last one. That's good. That's good. Now, when you are taking those variables from the parameter, again, use copy n. Don't write a for loop. This should be the same as what you have from previously. And you will, that will finish your constructor. Functions, you will have a matrix power function, calculate total damage, right? That's the total damage, just copy the logic from your previous project. You can see from the main that matrix power is not taking any parameter because you already have access to all of the class attributes. So no parameter needed, that's why it's so simple in main. Calculation detail will be the same as project 2. Mech class has 2 private members, defense matrix, micro missile. The constructor of mech does not take in any parameter, but you still need to write the constructor because you need to set default values for defense matrix and micro missile to 110. So you no longer read that, you just write that in your constructor. Every time you create an object, that will be initiated as default, as initial values. Functions, you have micro missile that takes in the class object battle. whenever you have a function that takes in another class, this is where you think about friend, right? Because when you take in a class and you can do nothing about that class, why do I take that in? Therefore, for us to actually write logic for micro missile, you will need to, and by the way, I simplify the calculation here. The calculation is different than project 2. You just do 3 times all the power plus 5. I think it's probably C. Did I do 3 times plus 5 times? Maybe. Was it 3 and
5 times and twice. Double and 5.
Oh, 2 and 5? Okay, so 2 and 5. Yes. Yeah, so 2, 3, and 5. I think there's a little bit different. I think it was 2. I'll look into it. Read the bus power from the cross battle, blah, blah, blah. Therefore, you want to make sure that they're friend, right? Whenever you're taking a parameter as an object, friend. Like 5. Once you have the friendship, it's pretty simple. You can have access to everything in battle. And also the load function will take in 2 parameters. Matrix power required, right? Missile power required. That's the same load function as before. However, a combined version, that's all. Remember we had 2 load functions, right? Overloading. We don't need that anymore. Just put them in one because they're all from the same class now. They should have access to everything, which is great. Like I said here, you can copy and paste code from your project 2 and check whether you, do you want to override the default value. And yes, that calculation. I changed number just to make my life harder. So we may have 60 this year, right? Yeah. I will fix that. This is when you know that I do not grade your project. There's a project that grade your project. There's a program that grade your project.
So we are going with 60, right?
Yeah, I'll change it back to match what you have this year. With that submission, so now you're gonna have the same file because I don't want you to have lab 4 as a requirement before you do this because you have a week. So just don't worry about multi-file compiler, multi-file debug. Just put them in the same file. If you already changed it, it's simple enough, just put that in one folder. One folder, one file, it will run fine. Okay? Put them in one file and upload that CPP file. And it's available now, due in a week. You don't have to complete it, right? You can get partial credit. So if you finish 1 class, right, you get partial credit. If you finish 2 classes, great. The main's already provided, so you don't need to worry about that. And yeah. Yes, question.
So for the folder we created for the entire class, can we just make a subfolder for when we want to run multiple CPP files, or do we have to make a separate new folder for that?
What do you mean a subfolder? Subfolder in what?
So when we started the class, you said to create one folder for the entire class.
Yeah.
So is it a folder
sub-
within inside that?
Exactly. Subfolder.
So we won't have to change any of the settings for
You
that?
don't need to change any of the setting. I mean, the setting in lab 4 you need to change, but other than that,
Okay,
everything else stays the same.
thank you.
Yes, subfolder. That's right. Rubrics provided, and I will go back and fix whatever number that I used.